In the last video, we were talking about the relationship between arcs and angles, but in this video, it's all about segments. Now, the two most famous relationships involving segments when you have a circle is that when you have segments that meet inside the circle, like chords inside the circle, part times part is equal to part times part. So A times B would equal X times Y. When you have these secant segments that are meeting outside the circle, then the outside part times the whole thing is equal to the outside times the whole thing. So it would be A times A plus B is equal to X times X plus Y. All right, but those are not the only relationships. Problem number 9 involves a different relationship where when you have these tangent segments, all right, that meet outside the circle, then, well, first of all, they are equal. So this segment and this segment are always going to be the same. Not only that, but the radius and a tangent segment always will form a 90-degree angle, which means you can use the Pythagorean theorem. So look, another thing is that a radius is a radius is a radius. So the radius of this circle is 12. But that also means that this radius right here is also 12. All right, this length is also 12 because it's also a radius. So right away that tells me that X is 12. Before we even begin, I know that X is 12. Now, as I begin to analyze this triangle, I see that I have a right triangle, okay, like this. See this as an entire triangle. Now, one side of the triangle is 12. What about the hypotenuse of the triangle? Well, I'm hoping I can get you to see that the hypotenuse of this triangle will be 20 because this portion to the lower left is 12. This portion to the upper right is 8. 12 plus 8 is 20. So the hypotenuse is 20. And really what we're looking for then is this side of the triangle, which I will call W. All right, call that W. So let's find W. How do I find it? The Pythagorean theorem. So W squared plus 12 squared is equal to 20 squared. The hypotenuse always has to be the one that goes by itself. So this is going to be W squared plus 144 is equal to 400. Subtract 144 from both sides, okay, and you're going to get W squared is equal to 256. Then you would have to take the square root of both sides. Bam, bam. So that is 16. So W is 16 up here. And I already told you that this segment is always going to be congruent to this segment. So W and Y are the same. So that means Y is also 16. All right, for problem number 10, you need to pay attention to the fact that we have a diameter here that is sort of being split up into two radii. So this red segment I just highlighted, that's a radius, and this green segment that I'm drawing now is another radius. So you know that those have to be the same, right? They're both the radius. So if this red segment is 10, then that means the green segment must also be 10. All right, now, what does that mean for the value of x? Well, you already see that this portion right here is 4. Hold on, I wanted to use a finer point. Okay, so this portion right here we know to be 4. So we should be able to tell what this portion is. If the total is 10, this must be 6, right? Because 6 plus 4 makes 10. So that's why x is 6. All right, so let's get that recorded. Now, what about y? Well, let's come back to this radius business again. How about that? Guess what the length of this segment is? This purple segment right here. You guessed it, that is yet a third radius. Radius, radius, radius. All of these have to be 10. Okay? So I know that that is 10. So now I can use the Pythagorean Theorem to find y. Because look, now you can just focus your eyes on this right triangle right here. All right, we've got 10 and we've got 6, and we're trying to find y. So there goes your Pythagorean Theorem. So 6 squared plus y squared is going to equal 10 squared. The hypotenuse always goes by itself. So that's 36 plus y squared is equal to 100. Subtract 36 from both sides. And then we've got y squared is equal to 64. Take the square root of both sides, and you get that y is 8. When you have tangent segments that meet, they are always going to be congruent. So that means that this tangent segment and this tangent segment are going to be equal in length. So I should be able to set them equal to each other. So that means that 5x plus 10 should equal 3x plus 14. Okay, so now it's just a matter of solving this equation. So let's subtract 3x from both sides, and that will give me 2x plus 10 is equal to 14. Then minus 10 on both sides, and then I have 2x is equal to 4. So when I divide both sides by 2, I discover that x is equal to 2. All right, so now I'm supposed to find y. Well, y does not actually take any calculation because all radii are congruent. And this green segment is a radius, and this purple segment is also a radius. So they have to be equal, obviously. So that tells me that y is 15. For number 12, let's use the theorem that tells us if the chords are congruent, then the arcs are also congruent. So these hash marks, these tick marks, tell us that the chords are congruent. That means the arcs are congruent. So those two expressions must be equal. So I can go ahead and set them equal to each other. So 8x minus 26 must equal 6x. Okay, great. So now it's just a matter of solving this. I think I will subtract 8x from both sides. So that's going to leave me with negative 26 is equal to negative 2x. And then I would divide both sides by negative 2. So that's going to be 13. So x is 13. Now, to find y, this is going to take a little bit more thought. It would be a lot easier if these two met at a single point, but there's actually an extra little arc right here that you have to be careful of. All right, don't ignore this. All right, this is an extra little, there's a gap here. So what I need to do is go ahead and substitute in the value that we have for x. Okay, so it will probably be easiest to substitute it in right here. So if I substitute in 13 right here, then that means I have 6 times 13. What is that? So I've got 6 times 13. That's 78. So that tells me that this green arc that I'm tracing is in fact 78. All right, so fine, this is 78. Well, guess what? I do not need to substitute 13 in here as well, because we already know that these arcs are the same. So if this is 78, that means that this is also 78 over here. Okay, so it's time to know how big this little gap is, the arc in between. Well, this is a diameter, so that means I'm looking at a semicircle. So if I subtract from 180, that should give me the remaining bit. So if I do 180 minus 78 minus 78, that leaves me with 24. So this tiny little arc right here is actually 24 degrees. Okay, so now I'm ready to find angle y. Angle y goes like this. Boom and boom. Okay, we mostly worked on this on the last video, where we realized that when you have an angle whose vertex is on the circle, the angle is half of the arc inside. The arc is double the angle. So I just need to take half of this. Okay, well fine. What is this arc? It's 78 plus 24, right? So that is 102. So this arc that I'm now tracing over in purple is 102. Okay, so the angle should be half that, which is 51. So that's why y is 51. For this problem, segment FG appears to be a tangent, but is it really? We need to prove whether or not this segment is truly a tangent. And before I do anything else, let's get some extra numbers in here. Notice how the radius is 8. Well, look, here's another radius, and here's another radius. Okay, so that means I've got, this is 8, and this is also 8. So keep that in mind. Now, more importantly, for what we're about to do, the hypotenuse of, well, okay, I shouldn't say the hypotenuse, because we don't know if this is 90 degrees yet or not. But this portion of the triangle right here is 14. 8 plus 6. So, focus on this triangle. Let me erase some of these extra lines. Let me start over. So focus on this triangle right here. Boom, boom, boom. If FG is tangent, then that means this has to be a 90-degree angle right here. Okay, but I said if. We don't know yet. So how can we figure out if this is a right angle? Well, if this is a right triangle, it should, the Pythagorean theorem should work. So that's really what we do. We check the Pythagorean theorem. We ask ourselves this question. Does 8 squared plus 12 squared equal 14 squared? All right, question mark. I need to scoot over a tiny bit. All right, we don't know yet, so I need to put a question mark on that. So in other words, and I might need more space. Okay, in other words, does 64 plus 144 equal 196? Okay, in other words, does, well, I can already tell this is going to be a no. Because what is this? That's 208. Does 208 equal 196? No. So that means that segment FG is not a tangent. Okay, and that's how you do it. You check to see, does the Pythagorean theorem work? If it does, that means you have a right triangle, which means this angle F is 90 degrees, which means this is a tangent. If the Pythagorean theorem does not work, then this is not a right triangle, this is not a 90-degree angle, this is not a tangent. Okay, so when you have these secant segments that meet outside the circle, we have found that the relationship is the outside times the whole is equal to the outside times the whole thing. Now, looking at the 6x and the 8, the outside is the 8. So when I say outside, I'm talking about the 8. Now, when I talk about the whole thing, that's going to be the 6x plus the 8. So outside times the whole thing. That's 8 times 6x plus 8. Now, that has to equal the outside times the whole thing for the other segment. Now, this is a special case because it is a tangent. It doesn't go inside the circle, so it doesn't create two segments. I only have one segment. That means that this 16 is both the outside and it's the whole thing. So I'm going to wind up writing 16 twice. All right? 16 is the outside, and 16 is also the whole thing. So a little distributive property here is going to give me 48x plus 64 is equal to whatever 16 squared is, 256. Subtract 64 from both sides. That's 192. Then we would divide both sides by 48. And that's 4. So x is equal to 4. When your segments meet inside the circle, intersecting chords, then we have learned that part times part is equal to part times part in this situation. So for example, we have the 4 and the x plus 3. The part times part becomes 4 times x plus 3 equals. And then we have part times part would be the 12 and the 6. Okay, so a little distributive property here, and I get 4x plus 12, and this will equal 72. To solve this, I'm doing minus 12 on both sides, so then I will have 4x is equal to 60, and then I'm going to divide both sides by 4. And that's looking like 15. Okay, so x is 15. Again, we have the secant segments meeting outside the circle. So the relationship again is outside times whole is equal to outside times whole. Okay, so we just need to be very careful about how we set this up, because on this problem, clearly the 3 is the outside for this segment, so that's fine. So I'll put the 3. Okay, now how about the whole thing? Well, the whole thing, I need to add these. I need to do 2x plus 1, okay, plus 3. I need to add these for the whole thing. But in that case, the 1 and the 3 are now like terms. So this is actually going to make 2x plus 4. All right, that would be an expression for this whole thing. So that's why I'm going to put 2x plus 4 inside of the parentheses, because now that's the outer part times the whole thing. The next portion also takes, we have to be very careful with it. In fact, I think I'm going to erase some of this, clean it up a little bit, because they did not actually give us an expression for the outer part. Okay, it's missing. It belongs right here. So what do? Well, we know that the whole thing is 15. And then this portion from here to here is 10. So if the whole thing is 15, what's this portion going to be? Well, obviously it must be 5. Okay, so this must be 5 for a total of 15. So great. So now I can say that the outer portion is 5. So I will say equals 5. And then the whole thing is simply 15. Okay, I'm not doing 15 plus anything. 15 is the whole thing. You can tell by this bracket that stretches from one end all the way to the other. So I simply put 15. All right, so that's why when we solve this, I will have 6x plus 12 is equal to 75. So then I subtract 12 from both sides, and that's going to give me 6x is equal to 63. Then it's time to divide both sides by 6. Divide by 6, divide by 6. All right, 63 divided by 6 is 10.5. Okay, last one, sort of. All right, once again, same formula applies. This is another outside times whole equals outside times whole problem. Okay, let's see. So 6 is the outside, and the whole would be 16, 10 plus 6. So 6 times 16. Outside times whole. Now for this lower portion, 4 is the outside, and the whole thing is going to be x plus 4, not 4x. That's a common mistake. You added the 10 and the 6 to get 16. You will add x and 4, x plus 4. So outside times whole is 4 times x plus 4. So I've got 96 is equal to 4x plus 16. All right, doing a little distributive property there. Subtract 16 from both sides. So that's going to give me 80 is equal to 4x. So that when I then divide both sides by 4, I'm going to get 20. Okay, so that is the last circle problem. So if you're randomly watching this from the internet and you were interested in learning about circles and segments and things, you should probably go ahead and stop the video now. There is an extra problem because my students have a little review question here. All right, so this is a little probability problem that we have to remember how to do. So find the probability of C given D. Well, these problems are easy because the given is going to be the new total. All right, when you do probability, it's always target over total. So this first part is always going to wind up being the target. And the second part, the given part, is always the new total. So D is the new total. So let's check that out. So here's the new total right here is D. All right, now since that is the new total, that means nothing else exists. All right, this is the total. It's everything, so there can be nothing else. So I would cross those numbers out. So that's why the new total is going to be 24. Okay, so that's why 24 goes in this denominator. Okay, I'm just adding 17 and 7. Now the target is C. Okay, now the only remaining number that represents C is the 7. All right, because the 11 is gone. So only the 7 is inside of the C circle. So that is the target. So I might highlight that as the target. Okay, so 7 is the numerator. All right, so 7 out of 24 is the probability of C given D. All right, now let's erase that and sort of reset for the last little bonus probability problem here. Okay, now this time we are given not C. All right, that's what the little prime here means, not C. So let's see, where are the numbers that are not C? Well, 11 and 7 are both inside circle C. So the 17 and the 16 are the numbers that are not C. So not C is the new total, right? So remember, this is always the new total. And then D will be the target. So I always do target over total. So everything I just highlighted will be my new denominator. So this is going to be what? 33. All right, so that's why the denominator is going to be 33. Yeah, whenever you have a new total because of the given, you should throw out everything else so you will not be tempted to use it. All right, this is the new total, everything else is gone. So now when I look for the target, D, I'm going to realize that the only D number that is left is this 17. So that's the target. So that's the numerator. That's why the probability will be 17 out of 33. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.